Hey, welcome back to Fat Mama Physics. In this video, we're going to do the second part of 2.4 Exponent Laws number 1. So a quick summary of what we just did. We looked at when we multiply powers with the same base, we have to add their exponents to simplify. On the other hand, if the powers, if they are dividing one another, then we subtract their exponents with the correct order in mind. So what we did was we did a few examples, and now we will look at more examples and also applying the order of operations. Okay, so we got examples. We have 6 examples. That's not too bad. So let's get started. Okay, so I want to do, actually, you know what, I'll do most of them. Maybe I'll assign 1 or 2 as middle of the video to pause for you to try. One thing I wanted to talk about in the last video, which I realized that I could do in this video, is to talk about the adding process. And why do I want to talk about that is because sometimes I would get students asking, if I'm adding my exponents, can I also add their... if I'm adding my powers, can I also add their exponents? And the answer is, unfortunately, you cannot. And there's a very good reason for that, okay? Because, remember, the only reason we are able to add exponents in using the exponent law is because the two powers are multiplying one another. And it's only by multiplying one another you're going to get more spaces that are multiplying one another. So let's take this long trail as an example. For example, instead of multiplying here, let's say I had adding, okay? Let's say I added these two up. Then, if that were the case, then my whole sentence would look like, here, I'm just move that there, then it's going to look like this. I'm going to have -7 times -7. So I'm breaking everything down with each individual power, but between the two powers, I'm going to have a plus sign. Okay? I'm going to have a plus sign, which means I can no longer add up all of these exponents to give me a total of 8. Because this is broken, like it's been cut in half. It's like, oh, how do you say that? It's like you cut a carrot in half. They're two separate pieces. There's no way to put them back together again. Okay, so that's why when we have adding exponents, you have to follow BEDMAS. You cannot do that first. And you cannot combine everything here together, okay? So adding and subtracting has no place in this section in exponent law rules. So let's do the multiplication first, okay? Using using our exponent laws, we know that that's going to give us, well, we have 6 to the power 2 plus, and 6 to the power 3 times 6 to the power 2. We add up their exponents. 3 plus 2 gives us 5. Okay, and if you don't want the exponents, if you don't want the brackets, then that's fine as well. So in this case, what we have to do is you would actually have to just put this in your calculator and add up the two numbers. So 6 to the power 2 gives us 36 plus 6 to the power 5. So I can't do that in my head. So that's going to be 6 to the power 5, 7, 7, 3 7s and a 6. Okay? And after adding them together, we're going to get 812. And that's our final answer. Because, actually, this instruction should have came first. Use use exponent law to show your work, and then order operations, then evaluate. Okay? So that's kind of how we do that. How about this? Why won't you... How about you give B a try, alright? Give B a try. Good time to pause the video. Okay, so hopefully in B, this is what you've done. using order of operations as well as your exponent laws, you were able to reason that you had to do these separately. So here, any number with no exponent always has an imaginary exponent of 1. So this here is actually 3 to the power of 1. If we simplify this, it looks like the following. Okay, I get 3 to the power 2 times 3 to the power 1. This is going to be 3 to the power of 3. Okay, and then I'm going to add, this is 6 to the power 2 times 6 to the power 3, and I'm going to add their exponents, so that 6 to the power of 2 plus 3 is 5. Okay, so that's a first step. Next up, we can write these numbers out by after putting them into the calculator. 3 to the power 3 gives us 27. And then 6 to the power 5 we found earlier, it's 7776. Okay, adding these together, we're going to get 3, 1, 3, oh that's 0, 1 up, 8. Okay, 7803. Okay, so that's how you would do B. All right, so I'm going to, how about this? I'm going to do C, then I'm going to give you a chance to do D and E. So let's do C together. According to BEDMAS, we always look at brackets first. So we will work on these brackets and copy everything down that is not within those brackets. Inside these brackets, we have negative 10 to the power of 6 divided by negative 10 to the power of 4. Both use the same base, and we just have to subtract the exponents. 6 minus 4 gives us 2. And then I have to subtract 10 to the power of 10 back over here. Next up is multiplication. That one comes next. And this is going to give me both our negative 10, same base. And then I get 4 and 2. This is multiplying. 4 plus 2 gives us 6. And then minus 10 to the power of 7. Now we are left with subtraction. So that does not follow exponent law rules, which means we just have to evaluate these numbers individually, then subtract this one from that one, which will get us a very ugly number, but no choice. So just by looking at this, we don't even have to use our calculator. We know that negative 10 to the power 6 is going to give us a positive number because this is an even exponent even when 10 is negative. So we're going to get a positive number, and it's going to have 6 zeros since this is 10 times itself 6 times. So there's going to be 6 zeros involved. So 1, 2, 3, 4, 5, 6. And then we're going to subtract. This is 10 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. And this is going to give us a very ugly number. Well, I mean, it's definitely going to be negative since my negative number, we're subtracting a bigger number than the first one. And that is going to give us 9 with 1, 2, 6 zeros. Okay? So that if I took negative 9, what is this? 9 million, and I subtracted this over here, that 1 million, I get negative 10 million. So now that we've seen some BEDMAS, I am going to ask you, ooh, I just realized something. D is actually tricky. D is actually a little bit tricky, but maybe not. Still, I think I'll give you a chance to try D and E. So good time to pause the video to try D and E. Alright, so the reason why D is a little bit tricky is that you can combine, there is a negative 5 in front, and we just have to be careful. That's actually not part of the base. So anyhow, let's go ahead and do it first. BEDMAS always goes first, so the brackets always go first. So we will have negative 5 to the power 4 in the front. And in brackets, I have 5 to the power 8 divided by 5 to the power 2. So I'll take 8 minus 2 since it's division. 5 to the power of 8 minus 2 is 6. And then closing the brackets, minus 5 to the power of 4. Next up, multiplication comes next. And don't forget, this particular power still has a base of 5. That negative sign in front is essentially I have -1 multiplying 5 to the power of 4. And then we have 5 to the power of 6 minus 5 to the power of 4. So let's actually multiply out these two things. 5 to the power of 4 times 5 to the power of 6. We know, so we drop down the -1. Multiplying means adding the exponents. 4 plus 6 is 10. So that's 5 to the power of 10. And guess what? This is going to make this a negative. And now we can just put all this in our calculator. We know that our answer is going to be negative because the negative is in front of the power. So 5 to the power of 10. That's 9,765, 625. 765, 625. Okay. And minus 5 to the power of 4, I believe, is 625. Hey, oh, yeah, yes, that's right. Let's see. So, what I'm going to do is, since both numbers are going to be negative, I'm going to add 625. Gives me, 766. Negative 766 and 250 was the remaining at the end. And there you go. There's our answer. Okay. All right. So notice that sometimes you have to tweak a power a little bit so that you can incorporate that into the rest of the powers for you to be able to simplify. And that could be extracting a negative sign out or doing something funny with the negative signs to make sure that that happens. Okay? All right. So you also had a chance to do E's, and this one is actually not too bad. First, we do the division, top and bottom. This is 8 minus 5. That's 10 to the power of 3 plus 10 to the power of 2. Hey, that's not too bad at all. This is just 1,000 plus 100. You're going to get 1,100. Easy peasy. Okay, next up we have the following. And you might be tempted to say, hey, that's 1, so I can just get rid of it. But usually a question will say that you have to use exponent laws first, regardless of how easy it is to simplify it first, okay? So let's do that. According to BEDMAS, division goes first. So that's these guys and these guys. So let's divide these two. It has the same base of -3. 5 minus 2 gives us 3. And then we're going to multiply whatever came afterwards. And then this part over here, the -3 to the power of 2 divided by -3. And remember, anything that does not have an exponent has an imaginary exponent of 1. So that's going to be -3. 2 minus 1 gives us 1. So 3 to the power, -3 to the power of 1. And then the next step is to simplify this guy, even with an exponent of 0. I get -3 and exponent of 3 plus 0. 3 plus 0 is just 3 plus -3 to the power of 1. So evaluating all of this, we're going to get, this is going to be a negative number since we have an odd exponent. And 3 to the power of 3 is 27. Next, we have -3 to the power of 1. That is just -3. And giving us a total of -30 at the end. Okay? So, there we go. All right? So that is exponent laws. You know what? I think I want to give you a challenge question. And there's space. So, give me a chance to make it up and we'll try it out. Okay, so I definitely made a little tricky one here. So here we have a combination of multiplying, dividing. So yay, no need to worry about adding and subtracting. But what I'd like us to do for this one is I like you to make I like you to simplify this as much as you can before you evaluate it. Okay, so it's very tricky. But at the end of the day, you should be able to get one number. And yes, you should be able to get one number to a single power. That's what you would want to do, okay? Yes, so think about it carefully, and I wish you good luck. Good time to pause the video. Alright, I will show you the steps I would take. Alright, so let's start with the top. Let's start with the numerator of this. You might be thinking, hey, I have two different bases. I can't do this. But remember, if I have negative 3 to the power 2, this is an even exponent. If this is even, it means my final answer is going to end up positive. So what that means is negative 3 to the power 2 is going to give me exactly the same results of positive 3 to the power of 2. So in fact, I will rewrite this as 3 to the power of 2 times 3 to the power of 5. And voila, I can combine the top now, okay? So, whoopsies. So that's one way how to treat negatives, is knowing what your final answer is going to end up to be and using that to your advantage. So I get 3 to the power of 5 plus 2 is 7. Now you might be wondering, oh, I have negative 9 on the bottom to the power of 2. How can I make a base of negative 9 to a base of positive 3? Well, remember, this is also to the power of 2, meaning I'm going to get a positive answer in the end. Just like the reasoning we had before, negative 9 to the power of 2, all of that is going to be equal to 9 to the power of 2 because both will give us positive answers. So let's change that first, okay, which will give us the following. Now you might be wondering, well, I can't divide, I can't do anything with exponents when the bases are different. But what happens if we could make the bases to be the same? Well, think about this. I have 9, okay, 9 to the power of 2 that just means 9 times 9. But wait a minute. What's the square root of 9? It is 3. So effectively, I could also write this as 3 times 3. And then this 9 over here is going to give me another 3 times 3. So 9 to the power 2 is exactly the same as 3 to the power of 4. So that means I can put it back in here and say this is 3 to the power of 4 instead of 9 to the power of 2. Now can I divide? Yes, I can. I have the same base of 3. 7 minus 4 is 3. So my final answer is 3 to the power 3. After evaluating, this gives me 27. If you don't believe me, put this original thing in your calculator and check it out. This is the power of exponent laws. So I thank you for watching. This is exponent law number 1, part 2. Stay tuned for exponent law number 2, section 2.5. Good luck with your practices. Keep up with those challenges. And Fat Mama Physics signing out.